Hey, I'm back. Want to go over, just kind of review some graphing concepts with you today. I suspect one of the questions will be a graphing question because that's something you can't necessarily look up if the data is made up. So I want to go over some of the key terms and how you do it. I want to also keep in mind that this program I'm using is kind of not working too well for me. So here we have a nice graph. There's my axes. So you have your y-axis, you have your x-axis. I actually screwed this up when I was making the initial graph. The responding variable is on the y-axis, and the manipulated variable is on the x-axis. Remember, the manipulated variable is the variable you change in the experiment, and it could be time, it could be temperature, it could be something that you are changing. So the variable that you change is going to be on the x-axis. All right, so we're going to make that the changed. And then whatever happens in response to that change is on the y-axis. So if you have, for enzymes, you change the temperature, and then your activity could be on the y-axis. And that's, how the enzyme responds to the temperature change that you created. A couple other points here. When you have if you're drawing or constructing a graph, you want units. You want to label the axis. So let's say if this was temperature, so I'd write temp, and then I'd say it's probably going to be Celsius. And then over here, maybe for the enzyme, I'd say, okay, well, that's activity. And then I'm going to have units with that, and the units will be given with whatever data set you have, so just use whatever they give you, say moles per minute or something. So that's the first point, right? Get your axes labeled, right? Units and information to tell you what you're measuring. And then the other point is having a properly scaled graph. You want to make a graph that's decently sized. You don't want a little mini graph. Oh, I got some numbers here. No, there's my graph. So make it decent size. I don't have any data to necessarily graph, but you're going to want to scale it properly. So, if this is 10 here, that'll be 20, that'll be 30. You don't want to make this, 70. Right? That's bad. All right, that would be 40. So keep the numbers consistent. If you're dealing with a large data set, you don't have to necessarily start 0. So let's say I'm starting with 1,000,000, and my activity is 1,000,000, would be incredibly large. But if I was 1,000,000 and I go up to 5,000,000, you don't have to start with 0. You can just define this as 1,000,000, and then this could be 2,000,000. All that's saying is that the x-axis is still here, starting from 0, but I've shifted this line up to the 1,000,000 mark. More than likely, it's going to start from 0. So this is all basic stuff that you probably knew how to do. There are different types of graphing as well, and learning how to identify what kind of graph you have is a bit of a skill. But I want to, while I have just a few moments here, I want to go over error and error bars. Often the data sets are going to have error bars. So if you have a bar graph, I'm kind of going off my axis now, so I have a bar graph. So you're going to have some sort of number over here. It's going to be a little bit different. And, I've got bar here, and I got one here. Doesn't necessarily have to line up. But when you're plotting points, make sure it's as precise as possible. So let's say I had 2 units of error, standard error. So what you would do is you'd have a line that goes up 2 units, 1, 2, and this is going to say plus or minus. So you have a line that goes up 2 units, make a little mark, go down, and you're going to go down 2 units. All right, so that's saying you have an uncertainty of 2 units. It could be plus or minus 2 units, so you do the same thing here, and go down, 1, 2, and up, 1, 2, down, 1, 2. Nice and easy. And it's the areas that don't overlap where you're going to have significant differences. Right, so this kind of overlaps. But these two data sets, if I have data A, B, and C, right, there would be a difference, a statistical difference in the numbers between A and C because they don't overlap. All right, there's this area here where they're not overlapped, and if you're looking for statistical significance or change, you look for the areas where they're not overlapped, and statistically similar areas would be where there's an overlap. Like here, these guys would be, there's a nice overlap here. Well, actually, it's down here, not paying attention. That's one way to look at it. So the error bars are there. Usually the error is given to you. Sometimes they'll give you a specific number. Sometimes they'll give you numbers for each number, which is a little bit more complicated. So I try to, and then you can get the same thing with a line graph too. You'll have, let's make this a nice straight line. You'll have data points, in the line, and you can also, it's kind of bleeding. The pen there is kind of bleeding, even though it's virtual here on the computer. It's bleeding pen. Imagine that. So you can also have error bars on line graphs. Let's just say it's a plus or minus 1. And lovely. I don't know why that comes popping up. In this case, you would take from the dot, from that point where the intersected the x and the y, and then you could just make the same situation, right? Bring it up and make a line. Bring it up, bring it down, 1, make the line. I wasn't very careful there. And you can do similar things with, do they overlap, do they not overlap? Oops, didn't mean to do that. But that's the error bars are an important thing to look at and be able to interpret on the graphs. So constructing a graph, having the axes labeled properly, having it scaled properly, easy points to get, also easy points to lose if you forget to do it. So be careful, be attentive, and we'll be practicing different graphing types later, but today let's see how well we can graph and start practicing, because you will see it on the test. Good day.